And this is the last video of our machine learning or Oracle machine learning for Python hands-on workshop. This time we're going to run sentiment analysis on free text based on data set of customers' reviews uh, on movies, on a movie data set with customer reviews. This data set has been provided and it is available to be downloaded at this link here. You can read the information on how this data set has been created and the details about this data set following this link. We already have it in the database we used for this hands-on workshop, and we have 25,000 movie reviews for training and 25,000 reviews for testing. They are free text reviews which have been gathered from a web repository. You may find some of the web HTML tags inside the reviews. They are not going to be considered by the text engine we use to read and understand the contents of the reviews. It actually uses Oracle text and Oracle data mining with text capabilities to read those contents, and the model we create, it uses a generalized linear model classification algorithm. It's a semantic binary classification, and we are going to use it to identify the sentiment and to predict the sentiment on the testing data, to identify the sentiment on the training data and understand and train the model, and then use it to predict the sentiment on the testing data. First, I'm going to select, let's say, one review just to see the format. It's basically free text. This is how it looks like. And we have also some HTML tags inside. We may have HTML tags in some of the reviews. It's not mandatory, but you may find it. And we also have the labels, which all the data is pre-labeled to train and test our machine learning model, to calibrate and evaluate the results which are returned by our machine learning model. This model has been, this dataset has been used in an ACL 2011 paper, and it has been created and provided by the following people. You see here on the video, and it has been used in the learning world vectors for sentiment analysis proceedings of the 49th annual meeting of the Association for Computational Linguistics, Human Language Technologies, Portland, Oregon, USA, Association for Computational Linguistics. And here you have the link to check all the details about the data set and also about the sentiment analysis execution. We're going to use Oracle Machine Learning with Oracle Text Support in our own database here. I'm going to read the data from the tables in two different data frames, one called train dat and the other one called test dat for training and testing purposes. You can see I have 25,000 rows in each one of them. And then I'm going to separate the training data into features and labels, into attributes, the sentiment, well, not the sentiment, the ID and the file content. These are the attributes, and the sentiment is the label. Is the label for my training, is the Y column, let's say. And in order to use Oracle text mining functions, we have to define some a lexer and a policy. I'm going to create the basic lexer, which is going to be used by my Oracle text mining functions, and then just a policy that this lexer will be used. This is actually the dictionary we are using to understand the contents of a free text record in order to be able to classify it into the final result, negative or positive. So I'm going to specify here the Oracle text settings using this policy, which will point to my basic lexer and token type. And I'm going to create my settings table. This is actually an array, and I'm going to use it into the model creation, into the model definition. This is where I create my generalized linear model, machine learning model, using classification. In this case, we have semantic binary classification, and using the settings we have specified in the previous block. And now I'm going to train this model, the GLM mode, using my train data, the attributes and the labels, the X matrix and the Y matrix. And I'm also specifying that by individual cases are identified by the ID column. This is the column I have in my dataset, identifying individual cases. Basically, each review is one case, individual case in particular. And it will take a while to train the generalized linear model in order to use it. It takes about 15 minutes to train this model with the data set we have for training. Remember, this is the sentiment analysis on free text, and it uses a semantic binary classification algorithm, generalized linear model. And it is not that easy to run. It requires some compute, and this machine is very, very small. So that's why it takes maybe longer on this particular virtual machine we have running in the cloud here. The confidence level is 95% here in the settings. This is the generalized linear model classification, binary classification details. Let's see if it converged. Yes, it converged. We can use it for predictions. So it means that this model is good for sentiment analysis execution on our data set. And let's use it actually to make some predictions on our test data. This is the data set we are using now to make predictions. I'm going to drop the sentiment because we don't have to give the model the answer we are looking for the model to give us, and we will add it back in the output just to compare it with the predicted values. So this is the execution now. It also takes some time. And here it is. We have 10 rows from our data set here with the ID column, the actual value, and the prediction. You can see not all values are accurate. For example, we can see here a false negative, which is actually a positive sentiment. We can check the comments or the review comments to see exactly why. Maybe we understand why this comment has been defined as negative by the system. Again, we have a false positive here. For example, the value is negative and the predicted value is positive. Again, this is wrong. And now we can calculate the accuracy based on the actual value and the predicted value. So let's score it using the score function to calculate the accuracy of this machine learning model. It is 85% accurate, which is quite good, given that we have given the default values and we didn't tune it at all. And now we can also return the prediction probability to see the probability for certain values to have that predicted value, and to see how confident the model is when it predicts those values from the data set. So you can see here, for example, this value which is wrong here has a very low probability. Maybe we can understand it already from the probability that the system is not very sure about this value. It's 52%, but also this value which is correct has a low probability. It has 51%, and the value is actually good. So let's say we can use it, but we have to take care about using the probability to identify good predictions from bad predictions. Again, this value which is wrong here in the negative values, it's a false positive. We can see it has a quite high probability. So we cannot use the probability just to identify exact wrong values and good values. Let's see the wrong predictions with the probability values, but just for the wrong predictions. Let's say in this case, I have false negatives only. Let's see if the first 15 false negatives, and then the first 15 or the last 15 false positives. So here we can see only the wrong values. In this case, we have false negatives and with the probability. So you can see we have all sorts of probabilities. We have low probabilities, but also we have very, very high probabilities, and the prediction is wrong. Again, for the false negatives, we can check maybe if we can use this probability to identify wrong values, but in this case, I wouldn't say we can use it because we have even high probability values, and it is not a rule that if the probability is low, then the value may be wrong. Let's see the last 15 of false positives. It takes a couple of minutes to run. And then the next is to calculate the number of false positives from the half of the data set, 12,500 pre-labeled. So we can see here also the false negatives false positives, they also have different ranges of probabilities, starting with 51% maybe, which is low, to 97%. So we cannot use it to identify wrong answers. Let's calculate the false positive number and the false negative number, just to from the total of the, so we have 25,000 rows in training and 25,000 rows in testing, and from both training and testing, half of the rows are positive and half of the rows are negative. So from the 12,500 negative, 1,800 are false positive, and from the 12,500 positives, 1,700 are false negatives. And this way we can create the confusion matrix. So let me show you how it looks like. Let me increase the font because here I see there is a, here it is. So from my test dataset I have used here, I have 12,500 rows which are actual positive, and 5,000 rows which are actual negative. But my machine learning model identifies actual positive 10,700 rows and 1,800 they are predicted. So from the actual positives, predicted positives are 10,700, and predicted negative are 1,700 rows. And from the actual negative, 10,600 are correct and 1,800 are wrong, are false positives. This is the confusion matrix. And this is the end of the hands-on workshop. Thank you very much for attending, virtually attending this Oracle Machine Learning for Python hands-on workshop.